We're taking a look at homework number 9. This homework is due at 5:30. Remember that exam number 3 is due by midnight tonight. We're looking at the very first question. The first question is asking about solving an exponential equation using inspection. That's me saying 4 squared is 16, 4 cubed, 64, so x must be the 3 for the cubed. If you have a situation like this, all this tells me is that this must be a negative number that would bring 1 over 7 to some power, right? But in order for this to go on the other side, it has to be a negative exponent, and this exponent is going to be 2 because 7 squared is 49. Whenever you're looking at powers of 10, a little bit of a hint here. There's 9 zeros there, so that means that this is 10th to the 9th power. There's a thing you can do with powers of 10. And then anything raised to the power of 0 is 1. And this time, if I am going to go ahead and solve this equation, I have to get the power alone. So I have to subtract 34 from both sides, which gives me 2 raised to what power is 8, and that power is 3. 2 times 2 times 2. What raised to the third power is 125? Well, I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed, 5 cubed, 5 cubed is 125. So t must be 5. Let's go to number 7. So the following power equation and check your answers. Remember that if I wanted to cancel out a fourth power, I could just raise both sides to the reciprocal, which is 1 over 4. That would mean these are multiplying, leaving p alone. And if I go into Desmos and I say 2401 raised to the power of 1/4, I'm waiting for Desmos. It would tell me that p is equal to 7 to the 4th power. And I can do this here, but I can only do this as soon as I get my power isolated. So we have 6m to the 7th power is equal to 270. I have to divide both sides by 6. I have to get this into the best form possible. 6 goes into 27 4 times. So I'm going to raise both sides now to the 1 over 7 power. I get 1.72222, so this is 1.7. Now, I just realized this too. Notice it says enter your answers as a comma separated list. This only happens if I have an even exponent. That means that there's actually 2 answers here, -7 and +7. Those are the answers. But here, because it's an odd exponent, we only have that positive version. So this is odd, so there's 1 answer. But if your exponent in a power equation is even, you have to have the plus and minus version of the answer. So for this one, I'm going to multiply both sides by 16. That will cancel out the bottom. Then I'm going to subtract 38 from both sides, divide by both sides by 4, and put this beautiful situation right into Desmos. So I'm going to go ahead and put in here 63125 times 16 minus 38 all over 4. And strangely, that gives me 243. And then I'll raise both sides to the 1/5 power. And that in Desmos gives me 3. So m is 3. She's not as bad as she looks. She's not as bad as she looks, right? Let's take a look at this graph. Is A positive or negative? Remember that A is the starting population, B is the multiplier. So the starting population is right here. So A is positive, and this is probably because, actually, I'm going to see what this says when I pull down. So I'm going to take a look and see what that C is. This is number 10. I'm looking on my computer really quick. A is positive because the graph is, it says above the horizontal asymptote, below it be above. Is B greater than or less than 1? This is greater than 1, and that is because it's increasing, so that shows us it's growing. The graph is increasing. Domain, how far left, how far right? It goes forever and ever in the negative and forever and ever in the positive, left and right. Going down and up, it starts at 0 and goes to infinity, and neither of those are included, so I have parentheses for both. We are going to go over here to 11. Is A positive or negative? It's negative this time. It's below the horizontal asymptote. Is B greater than 1? And it is greater than 1 because this is increasing. It's increasing. Domain is negative to positive infinity, and this goes from negative infinity to 0 without anything included. That is what that one looks like. Let's keep it going. Number 12. This question has several parts, and they want you to find an equation for the model. This has to be put into Desmos. Has to be put into Desmos, and we are going to use the exponential regression. So I am going to go ahead and I am going to share the classroom. So give me one moment. So I have Desmos here. It's all shrunk down and really tiny. And I've got this link from the class number 8 link on the virtual classroom. It says exponential regression Desmos. I'm just going to put in here all of my ordered pairs. I'm hoping you can see this well. 25, 6.3, 75, 3.1, 125, 1.5, 175.8. And what this is going to do is it's going to give me right here the A and the B. And when I put this in here, I'm going to make sure that I say f of x equals, depending on what they tell me, if they say round it to the nearest whole number, it would be 9 times 1 raised to the power of x. But it's not going to do that because this is actually less than 1, which means it's decreasing. They probably told you to round it at least to 1 decimal or 2 decimals or something like that. And I also can answer my questions using this. Like the domain of this is negative to positive infinity. The range is from 0 to positive infinity. We're talking about left to right and down to up. They might ask you some other questions, but they're asking you to look up how much soil is at year 150. Well, x is year, so I'm going to say x equals 150. And then I'm going to go over here and find where that intersection point is, and that is 1.07. So that's what I would put for that last piece, 1.07. If I'm looking at 13, they want me to find an equation for this model and how many days remain after 9 rolls. I'm bringing this back and I'm going to refresh it so that I can get a new fresh. I don't know if it's going to let me. Hold on a minute here. I want to refresh. I don't know if this is. Oh, wait, hold on a minute. I get it now. Browse. Refresh. Beautiful. 0, 1, 2, up here, 100, 85, 69, 3, 4, 5, 6, 7. Let's do it. 3, 4, 5, 6, 7. Oop, go down here. 55, 49, 43. 33, 29. Okay, my equation, my model equation, here it is. A is 99.9877, And again, this is decreasing. 0.8349 is my multiplier. And they are asking me to find an equation. There it is. How many dice will remain after 10 rolls? So I have to use, I'm going to go back to my browser. I'm going to use my table. I'm going to put 10 in here. If I can figure out how to type into this. Hold on a minute. I was just doing it. Where did I go? I have to probably do this. Browse. And 10. There we go. What happened? It's not telling me. What happened? This is something my kid would say. Let's delete. I need to know when x is 10 for my model. So I have to go down here and say x equals 10 to see what happens. Right here, 16.467. 16.467. That is what we've got for the second part of this question. I'm going to get rid of that for a moment and go down here. Again, they're trying to get us to find an equation. Exact same thing that we did, except this says use the first and fifth. They only want you to use these two. They only want you to use those two. So in your calculator, you're putting this one and you're putting this one and you're using nothing else. This stuff they gave you, and it's like, doesn't even have anything to do with it because they just asked you to do the first and the fifth. So that's important. I already can tell by looking at this that A is negative 23. So when you do this, hopefully that's what you get. Who knows? You're going to have to do this using this stuff. Sorry, not the stuff, but you're going to have to use this in Desmos and see what you get. Don't forget that the exam is due by midnight. And if you have any questions, you can send me a message. And I will see you guys on Tuesday.